Hey, Ace Trig students, Mr. Minier here. Today we want to briefly go through how to sketch a curve of a tangent or cotangent graph. Again, we're just sketching a curve of these two graphs. Before I get rolling here, I want to show you what they're going to look like from the TI Inspire calculator. The ones in blue here are the tangent curves. Notice tangent curves are increasing throughout. There's several breaks in them. There's several different sections. That's because tangent by nature is the sine over the cosine. So it's a rational expression. It's a fraction. And when that denominator equals zero, we're going to have a lot of asymptotes. It's repeating quite frequently. We discussed before that tangents repeat every pi, not every 2 pi. So it actually repeats twice as often. So the tangents are the blue ones, and then the cotangent functions are the ones in red here. Cotangents, you'll see, are decreasing throughout. They're moving down. They look a lot like tangent. There's several breaks because, again, cotangent is actually a fraction of cosine over sine. So whenever that sine value equals zero, the cotangent will have an asymptote running through it. So that's what we're kind of looking at. That's what these are going to appear. Where I make a little sketch of it. So keep this in the back of your head as we do these. So to make these happen, a few little rules. First off, think about our values for tangent and cotangent. And let's think about multiples of pi over 2, actually. I'm going to speed this up a little bit. And I'm going to do the tangent value and the cotangent value. Tangent's like your slope, remember. So out here at 0, we have a 0 slope. Tangent's going to be 0. Cotangent's the reciprocal of that, so it's going to be undefined. At pi over 2, moving straight up and down, vertical slope for tangent is undefined. Cotangent's the reciprocal of that, and it's 0. Going out to pi, your tangent has a 0 slope. Cotangent's undefined, and at 3 pi over 2, your tangent's undefined and your cotangent is 0. So kind of keep those in mind. Other big things here. As far as pieces to label when we graph these, there's a lot of the same ideas that we've been working with amplitude and vertical shift and phase shift and W values and periods, but the period on these is not 2 pi over W. The period for a tangent or cotangent curve is only pi, so it's pi over W. That's a big difference from what we've been doing the last week or so. Key points to get an accurate sketch then are not your period split into 4 quadrants. If the period is only pi, we only need 2 quadrants. So your key points are your period divided by 2 when we make these happen. Period divided by 2. And I only need you to sketch 1 period. I'm not going to make you do 2 periods on these. All right, I want to do the cotangent one first. It does kind of work out a little bit cleaner than tangent typically. With this, let me erase that real quick. Let's get in the habit of labeling all our pieces again. This is a basic cotangent curve. No value is with the x there, so that's a W of 1. That means our period is going to be pi over 1. Not 2 pi, but pi this time. So the period's a pi. Your key points are going to be that period of pi split into 2, so every pi over 2. Your amplitude is 1. The number multiplied out to the front. We're not adding or subtracting anything around it, so the vertical shift is 0, and the phase shift is 0. We're not adding or subtracting anything with the x value. Things are kind of similar here. Phase shift tells you where to start the x-axis, 0. Key points tell you how much to increase by. Pi over 2, pi. Period is how long it takes to repeat. So from 0 to pi, we did a period. As far as what happens on this one, this is a cotangent curve. At 0, we said over on the top left that cotangent is undefined. That's an asymptote. At pi over 2, we said that cotangent equals 0. And at pi, cotangent is undefined. There's your other asymptote. And if you remember back to our calculator, cotangent is the one in red, we can see that cotangent is decreasing. So this piece where my cursor is going right now is tracing what we just graphed between 0 and pi. And it kind of hugs the asymptote, dives across the middle, and hugs the far asymptote. That's cotangent. If I come over here and try to do the same thing for tangent, again, we have a W value of 1. The period is pi over W. Pi over 1 is a pi. Your key points are period divided by 2 this time, pi over 2. We have an amplitude of 1, vertical shift of 0, and phase shift of 0. Phase shift tells me to start at 0. Key points tell me how far to move, pi over 2. And I'm going to stop right there for a second. Tangent's a little bit different. Notice at 0, at the start, your tangent curve above this here has a 0 value. So that is a point. As I increase to pi over 2, that's where your tangent curve gets its asymptote, being undefined. If I continued on forward, I would have another point. I'm going to have a piece of 2 curves. I really want a point and 2 asymptotes to hold it together, like we did with the cotangent problem, where I have an asymptote, a point, and an asymptote. So instead of moving forward, I'm going to go backwards on this. So again, here's 0. If I go backwards, we're going to be undefined. And if I do move backwards, that's a negative value. So it's going to be a negative pi over 2. That is your second asymptote. And remember back to a tangent curve here, the blue ones, we just kind of did this one where the cursor is going right now, cutting right through 0. It increases, asymptote at negative pi over 2, asymptote at positive pi over 2, increasing throughout. So here, we're going to hug the asymptote on the left side, increase, dive across, hug the asymptote on the right side. When I lay these out, I remember a couple of things. Tangent curve, I know, always moves up. It increases, and it starts. The phase shift is a point. It gets to the point. Tangent holds its head up high, and it gets to the point of things. Tangent's kind of prominent, more important. People think about tangent more often. Whereas cotangent kind of gets neglected. We don't use cotangent a lot before a trig class. It moves down. And at this phase shift, when we started cotangent, it had an asymptote. So cotangent kind of holds its head down low, bit of an asymptote here at the start. Tangent gets to the point, increases. Tangent starts with a point, increases throughout. Cotangent starts with an asymptote, decreases throughout. That's the big difference. Kind of like how a sine curve starts with the middle value and a cosine curve starts with a maximum value. All right. So now that we know that, we can kind of speed things up a little bit. Ideas on this, properties of these two functions. We've already laid out at the period, a normal tangent cotangent curve. The period is pi. The range on both of those, it's not inhibited at all with the y values. So it's all real numbers for tangent and cotangent. Domain, there's a lot of breaks. So for a tangent curve, you had a break, x does not equal every odd pi over 2k. So that means like 1 pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2. While on cotangent, x does not equal every pi k. So every 1 pi, 2 pi, 3 pi, 4 pi became an asymptote. All right. We're not going to worry about these 5 and 6. Let's jump right to these curves. Example 7 here. Again, all your little pieces. This one, we have a w value of 1/3. That means our period is pi, not 2 pi, but pi divided by 1/3, which is 3 pi. We have key points at the period of 3 pi, split into 2 quadrants, 3 pi over 2. We have a vertical shift of 0, an amplitude of 1, and a phase shift of 0. So the curve phase shift of 0 tells me to start. At the start, tangent is going to have a point. Tangent gets to the point. I move forward a key point of 3 pi over 2. That will be an asymptote. And I also want another asymptote, so I'm going to go backwards on this one. Your key point, 3 pi over 2. That will be the second asymptote. And tangent curve increases. So hug the asymptote, dive across the middle, hug the asymptote. That's all we need to have. A point and 2 asymptotes with the values labeled across the x-axis. Our next one, w value is 1. That means the period is pi over 1, which equals pi. The key points are the period of pi divided by 2. We have an amplitude of 1. This 5 now is being added, just like on sine and cosine problems. Numbers added around is the vertical shift. Phase shift, there's nothing with the variable. It's going to be a 0. Start at the phase shift of 0. Tangent starts with a point, but the vertical shift this time, that vertical shift moves your point 5 units up. So at 5 is the point we're going to place. Move forward a key point, which is pi over 2. That's your asymptote. I need another asymptote, so I'm going to go backwards from that, which would be negative pi over 2 in this case. And we hug the asymptote, increase across that point, hug the asymptote. All right. Example 9 here. We have a cotangent problem. Our w value is 1. That means the period is pi over 1, which equals pi. Our key points are period of pi split into 2 quadrants, pi over 2. Amplitude, number in front is a 1. Vertical shift is 0. This time we have a phase shift of pi over 2. So on the graph, phase shift tells you where to start. So we have 0, pi over 2. That's the beginning of the problem. Cotangent begins with the asymptote. Move forward. Key point of pi over 2. Pi over 2 plus pi over 2 is pi. That is the point for a cotangent problem, and it's at the vertical shift of 0. Move forward another pi over 2 to get our second asymptote. Cotangent decreases. We hug the asymptote on the left, dive across the middle, hug the asymptote on the right. And last, on this one, we need to make sure that W value of 2 needs to be factored out of the problem, just like sine and cosine problems were. So this is really y equals -3 plus cotangent of 2, theta plus, take 2 away, and we get pi over 4. Now we can label our individual pieces. Where the W value is a 2, that means the period is pi over 2. Key points are pi over 2 over 2, which is pi over 4. Amplitude is 1. Vertical shift is the -3 out in front. And the phase shift is a negative pi over 4. The opposite of the sign within the parenthesis after you factor the 2 away. Phase shift tells us where to start the x-axis, negative pi over 4. This is a cotangent curve, so the start represents the asymptote. Key points tells us how far to move. We're going to move pi over 4 in front of that. So negative pi over 4 plus pi over 4 gets us to 0. That's going to be the point we place, and that's going to go at the vertical shift of -3. And then move forward another key point, so another pi over 4 puts you at pi over 4. That will be our second asymptote. Cotangent curves always decrease, so we hug the asymptote on the left, dive across the center, hug the asymptote on the right. All right, guys, that's all we got. You have a worksheet on tangent, cotangent curves. Try to take care of that. See you back in class here soon. Take care.